We're going to continue with factoring, and today we're going to look at a method that's sometimes called trial and error. It is sometimes called guess and check. Some teachers teach it, and they call it the box method. Have any of y'all learned it as the box method? Okay, good, because I don't use the box method, so I'm not going to be confusing you, I hope. All right, in order to be really good at trial and error, we need to review FOIL, which is the acronym first, outer, inner, last, which is a way to multiply two binomials. So let's take a look at about 4 examples. Let's look at x plus 3 times x plus 5. What's the product of the first terms? X times x. It will give you x squared because you'll add the exponents. Now, the outer product is 5x. The inner product is 3x. And if you add those two together, you get 8x. And then the product of the last, and I'm moving kind of slowly with this. I know most of you are better at FOIL than I'm leading you to believe, is 15. So is everybody okay with that? Okay, first, outers plus inners, and last. Let's take a look at another example. And the only thing I'm going to change up in this is I'm going to make it x minus 3 times x minus 5. Once again, the product of the first is x squared, x times x. The outer product this time is negative 5x, and the inner product is negative 3x. They're both negatives, so what do? Add them up, keep it negative, negative 8x. What's the product of the last? It's still positive 15. So if you take a look at those two, you notice that both of them got as their last terms positive 15. But the first example got a positive 8, and sure enough, both of the signs here were positive. The second one got as its middle term negative 8, and both of the signs were negative. Okay, so I'm just asking you to make some observations. Yes, question?
How did you get the 8x?
I got the 8x, this 8x, by adding the outer product, which was negative 5x. Negative 5 times x is negative 5x. The inner product is negative 3 times x, which is negative 3x. A negative 3x and a negative 5x add together to be negative 8x.
I'm sorry, I don't know. Maybe the way I study is different, but I just want to be clear. I thought x and x is x. Where?
Okay, in multiplication, x times x is x squared. But in addition, where you have a negative 3x and you're adding it to a negative 5x, when you add them, you simply add their coefficients. So if I had written down all the terms, I would have had x squared minus 5x minus 3x plus 15. And to add these two, they are like terms. All I do is add their coefficients and keep the variable. Okay? And I hope that you notice the sign patterns. And I'm asking you to look at it now, and then we'll summarize together in a minute. All right, let's look at another one. Number 3, what if I have x plus 3 times x minus 5? Let me scoot this up. The product of the first, x times x, is x squared. The outer product is negative 5x. The inner product is positive 3x. Now this time they have different signs. So if I have one positive and one negative, I subtract, keeping the sign of the greater one, from minus 2x. Product of the last is minus 15. So this time I got a last term which was negative, and that makes sense because I multiplied one positive times one negative to get that minus 15.
Can you do that one more time?
Sure. The product of the first, x times x.
Yeah, I got that.
Okay. Okay, the x squared. So the outer product, because the 5 is negative, gives me negative 5x.
Oh, okay.
Okay, and the inner, because it was positive, gave me positive 3x. And since one of them's positive and one of them's negative, I subtracted 3 from 5 to get 2. The sign of the bigger one was negative, so it's negative 2. Okay? All right. And the last example, before we start trying to draw some conclusions, what if I had x minus 3 times x plus 5? All right, using FOIL, the product of the first, x times x is x squared. The outer product is x times a positive 5, so it's positive 5x. The inner product is negative 3 times x, which is negative 3x. Again, they have different signs. So with different signs, I always subtract, keeping the sign of the greater one. This time it's positive 2x, whereas the last time it was negative 2x. The product of negative 3 times positive 5 gives me negative 15. Our job in section 6.2 is going to be, starting with the trinomial, trying to come back and rediscover what the factors were. So my first hurdle is to figure out what kind of signs things are going to have. And there are some very definite patterns. Let's go back up to the first two. Looking at this, I want you to look over on this side. Okay, look at the trinomials. Look at the first one. Look at the last sign. It's positive. If the last sign is positive, what that tells you, because both of these have the last sign that's positive, what it tells you is that the middle term's sign tells you what these two will be. The middle term sign tells you what these two will be. To get a positive 15, I either have to have a plus times a plus, or I have to have a minus times a minus. That's the only way to get positive 15. Which case is it? Is determined by the middle sign. If the middle sign is plus, they were both pluses. If the middle sign is minus, they're both minuses. Conclusion: if the last sign is positive, the middle term tells you what the two signs will be. Okay? Now, let me go back, and I want to show you something under sign patterns. You can print this if you want. Sign patterns for factoring trinomials. I don't have terms in there, I just have boxes. If the last sign, if the last sign is positive, then both signs in the factors must match the middle sign. Okay? That's what you need to remember. If the last sign of a trinomial is positive, both signs match the middle term. Would you like me to write that down? If the last sign is positive, comma, both factors match the middle sign.
When you get ready to go print this right here,
Uh-huh.
will that be on?
It will not unless, no, it will not. I will include this though, and it is being included as part of the video. So if you needed to see it again, you could look at the video. All right, let's go back to those examples we were looking at. What happens if the last sign is negative? Then there is always one of each, one positive and one negative, one positive and one negative. It doesn't matter whether the middle term was positive or negative, there will be one of each. Now, the sign of this will help you decide what number to put in the right place, but that's a discussion coming up in a few minutes. So for right now, if the last sign is negative, then you are guaranteed that you will have in the factors 1 plus and 1 minus, always. So if I went back, if the last sign is negative, this is back to the sign patterns, then you always get a plus and a minus, a plus and a minus. It didn't matter what the middle term was. You get a plus and a minus. So if the last sign is negative, you get 1 plus and 1 minus in the factors. Always. Okay, so if this last sign is negative, I guarantee you you're going to have 1 factor with a plus, 1 factor with a minus. If it's negative, you get 1 factor with a plus, 1 with a minus, and it is irrelevant what the middle sign is in making that determination. All right. So now that we have taken a look at that, let's look at the problems, the MyMathLab problems in 6.2. The instructions are going to tell me to factor, and I'm going to be factoring trinomials. So if you printed these notes, then you've got room to work right there on your paper. And the first question you see should be x squared plus 12x plus 32. I need to factor this. Here's my questions that I ask myself. Number 1, I think about the flow chart. Is there, to all 3 of these terms, a greatest common factor? And I think it's no. There's not a number that goes into 1, 12, and 32. Okay? And they don't all have x's. The next thing I do is say, well, how many terms do I have? Because if I have 4, I'll do grouping that I learned yesterday. But I have 3. 3 tells you to try this new technique that we're just embracing called trial and error. So the first thing I do is put down my parentheses. The next thing I do is think about signs, because we hopefully know the patterns. What does the pattern do? The pattern says, well, look at that last sign. That's got to be your first consideration. If the last sign is positive, what did I say? They both match the middle term. And what is the middle term?
Positive.
Positive. So I will have a plus and a plus. Okay? So the rule says, if the last sign is positive, the middle term determines both of those signs. Okay, now we have to think about FOIL, first, outer, inner, last. First is pretty easy. This first position times this first position has to give me x squared. So it has to be x times x. That part's easy. The next thing I have to do is think the last position times the last position has to give me 32. But there's more than one way for that to happen. So I'm going to write down the ways it can happen, and I'm going to write it over here. I'm going to switch over to blue. Do you agree that 1 times 32 would give me 32? And 2 goes into it 16 times, so 2 times 16 would work. 3 doesn't go into it, but 4 does. 4 times 8. And I believe those are all my possibilities. Those are all the ways that I could get 32. Only one of them is right. Now, how do I know which one? It is going to be the outers plus the inners that's going to tell me. Now, if I put in, and I'm going to erase, so maybe you don't want to write this down. Maybe you don't want to write down what I'm about to do. If I put in 1 and 32, what would my outer product be? 32x. What would my inner product be? 1x. Does 32x plus 1x add up to be 12? No. So that was not the right choice. Do you agree that since you're just multiplying whatever you put in those spots by 1, that it doesn't matter whether you put them in here or you just look at them out here? Is 1 plus 32 equal to 12? No, then that can't be the right choice. Is 2 plus 16 equal to 12? Then it can't be the right choice. Is 4 plus 8 going to equal 12? Then that's your choice. Put in the 4, put in the 8, and check it one last time. X times x gives me x squared. And I'm sorry, I accidentally erased my parentheses there. The outer product is 8x. The inner product is 4x. Do those add together to give me the middle term of 12x? Yes. And 4 times 8 is 32. I've got the factors. So in section 6.2, oh, and it's blue again, what you can count on is that it's going to be a plain old x squared. So it's going to be easy to determine what goes in the first spots, x and x. Then you're going to have to worry about how am I going to get a 32? And I have many opportunities to get 32, but they have to combine through addition to give me the middle term. Okay, so there's two criteria. Multiply together to give me the last term, add together to give me the middle term. Let's look at number 2. Let's factor x squared minus 6x plus 5. Whoops. All right, is there a common factor? No. It has 3 terms, which means I'm going to look at trial and error. So I start by putting down my parentheses. Once I've made a determination that I'm going to use trial and error, then I think about the sign patterns. The last sign is positive. So what does that tell us about the 2 signs? No? Both be negative. Okay, the rules are if the last sign is positive, both signs in here match the middle term. If the last sign is negative, that's when you get one of each. Okay, so they're both negative. I know that to get x squared, I need x times x. So that's taken care of. 5. Well, 5 is a prime number. There's only one way to get 5, and it's 1 times 5. Does 1 plus 5 equal 6? Then those are right. And I'm going to check it. X times x is x squared. The outer product is negative 5x. The inner product is negative 1x. Those add up to be negative 6x. And the product of the last, negative 1 times negative 5, is positive 5. I need to check it because you could be making one thing work but not paying attention to the fact that something else didn't work. So 2 criteria. You have to have the last multiply together to give you the last, but they have to add together to give you the middle. Let's look at number 3. I have x squared plus 14x plus 49. My instructions are going to say to factor this. Is there a common factor? No. It's a trinomial, so I'm going to go with trial and error. Okay, signs. When the last sign is positive, they both match the middle term. And I already heard people saying positive and positive. To get an x squared, I know it is x times x. To get a 49, I don't know. There's more than one way. It could be 1 times 49. Do those add up to be 14? Then I don't think that'll work. Another way to get 49 is what? 7 times 7? Do those add up to be 14.
Yeah.
Then that's what I'm going to choose. I'm not going to feel fully confident until I do FOIL with my potential answer. The product of the first is x squared. The outer product is 7x. The inner product is 7x. Those add up to be 14x. The product of the last is 49. You do not, say you're taking a test for me, you don't have to show me that you're checking this, but I think you should at least mentally check it. All right, number 4. We have x squared minus 5x minus 36. All right, is there a common factor? And by the way, before this lesson ends, the answer to something will be yes. Okay, but it's a no over and over as we start. It's a trinomial, so I'm thinking about trial and error. This time the last sign is negative. What does that tell you?
Negative.
One of each. When the last sign is negative, it is always one of each. When the last sign is positive, it is 2 that match the middle term. All right, I know it's going to be x and x. Now, I'd like you to take a little look up here. My outer and my inner products. Does everybody see that the outer product will be a negative quantity? Because it's an x times a negative number. The inner product will be x times a positive number. When I add a positive and a negative, what do I end up doing? You end up subtracting.
Yeah.
So when the two signs are different, you're going to be looking for a difference that is 5. Not a sum, but a difference. When the signs are different, looking for a difference. Okay, so here I go with all the possibilities to get 36. It could be 1 times 36. Do those have, and I'm going to even write it on here, a difference of 5? No. Okay, so I tried 2. 2 goes into 36 18 times. Do those have a difference of 5? No. All right, 3 goes in there 12 times. Do 3 and 12 have a difference of 5? No. 4 goes in there. It's 4 times 9. Do 4 and 9 have a difference of 5? Yes. Voila. I've got the right combination. Now, when the signs are different, it does matter where you put them. Okay? You want the difference of these to be 5, and you want the bigger one to be negative because you got negative 5. So what will I put in the negative spot? 9. And 4 over here. And by the way, if you put them in the wrong places, you're going to discover that when you check it, and then you're just going to change them. All right, so the product of the first is x squared. The outer product is negative 9x. The inner product is 4x. Those have a difference of 5. The sign of the big one was negative. That's good. Positive 4 times negative 9 is negative 36. Check it with FOIL. Number 5. I would like you to do this one. Would you factor x squared plus 4x minus 45? And I will stay silent for just a minute. Okay, let's take a look at this together. Is there a common factor? No. It is a trinomial, so I begin with trial and error. The last sign is negative. What does that tell you? One of each. To get an x squared, I know it's going to be x and x. 45 has different sets of factors. 1 times 45. Now let me pause for just a minute. The outer and inner products, will I add them together or will I really take a difference? It will be a difference. And how did you know that? The signs. One's positive and one's negative. So I'm going to be subtracting. 1 and 45 do not have a difference of 4. Okay? 2 doesn't go into that, but 3 does. 3 goes in there 15 times. Do 3 and 15 have a difference of 4? No. All right, 4 doesn't go in there, 5 does. 5 times 9. Do 5 and 9 have a difference of 4? Yes, so that's my choice. When I look at this, I see that not only do I get a 4, but I get a positive 4, which meant the big number had to be positive. So the 9 will go here, and the 5 will go here. And I'm not calling it done till I check it. Product of the first is x squared. Outer product, negative 5x. Inner product, positive 9x. Do those have a difference of positive 4? Yes. And a positive 9 times a negative 5 does give me negative 45. So make sure you're checking things. Let's look at number 6. How'd y'all do on that one? Did you do okay? All right. Number 6, x squared plus 5xy plus 4y squared. Is there a common factor? No. But please notice something characteristic about this trinomial. All the others that we've done have been an x squared, something times x, and then a constant. This one, just a little bit different. It has an x squared. It has what's sometimes called a mixed term. It has xy, and then it has y squared. That's not going to be a problem to us. There's no common factor, 3 terms, go into trial and error. Let's focus on signs. That's what I like to do first. This is a plus sign, which says what? They're both the same as the middle term, both plus. So when I say, what are the signs? You look straight at the last one. If it's positive, they are both this sign. If it's negative, it's always one of each. Okay, so I got pluses. Now, I know that it's x times x to give me x squared. To get 4y squared, I'll worry about the numbers in just a minute, but do you agree that there must be some y's in there? That's what's a little different about this particular example, is I've got to keep the y's. Easy to forget. Math Lab will simply tell you you're wrong. I might be slightly forgiving on a test. I might count off 1 point. But do your best to try to remember it. All right, now my outer and my inner, because they're both positive, I'm going to be looking for a sum of 5. So for 4, it could be 1 times 4 or 2 times 2. Which of those will give me a sum of 5? 1 and 4. And it doesn't matter at all where I put them because it's all pluses. Check it. X times x is x squared. Outer product is 4xy. Inner product is 1xy, even though the 1 is not usually written. Add them up for 5xy. Product of the last, 4y squared. If you were typing this in to my math lab, most probably you would just type in x plus y times x plus 4y. You would not type in the 1, that 1 right there. Is that okay? So don't be surprised if you have squared term on the front and a squared term on the back, and the mixed term in the middle. Let's look at number 7. Yes. All right, let's factor a squared minus 10ab plus 16b squared. This time I have 2 variables. I have an a squared on the front, a b squared on the back, and an ab in the middle. There is no common factor to all those terms. I will try trial and error. The signs. Go to the last sign. It is positive, which tells you they're going to both match the middle term, both minus. I know that I'm going to have an a times an a to get a squared. I know that whatever the numbers are in the last spots, they're going to have B's with them. And now I'm going to work with the number 16. Because the outers and inners have the same sign, I'm going to look at a sum. I need the sum to be 10 for 16. Is it 1 times 16? Do those add up to be 10? Is it 2 times 8?
Yeah.
Yes. There's no reason for me to look at other possibilities. There is another possibility. There is 4 times 4, but I don't really care about that because I already found the right one. So throw the 2 and the 8 into spots. Because the signs were the same, I didn't care which one went where. And I get a times a is a squared. Outer product is negative 8 ab. Inner product, negative 2 ab. Those combine to be negative 10 ab. The product of the last, negative times negative gives me positive 16b squared. Okay, are you remembering the sign patterns? It will help you. Number 8. Well, come on. Oh my goodness. All right, let's factor 2x squared plus 28x plus 96. Now, what's that first question I keep asking over and over? Is there a greatest common factor? And finally, the answer is yes. If I look at 2x squared plus 28x plus 96, there is a common factor of what? 2. So I have to factor that out first. Now, if you want to, if it's helpful to you, show where you are dividing that 2 out. If that helps you. That gives you x squared plus 14x plus 48. Now, yesterday, when you were working on section 6.1, if you found a common factor and factored it out, you were finished with the problem because you didn't, at least as far as our book is concerned, you didn't know to try anything else. Now you have more knowledge. Not only did it have a common factor of 2, but this polynomial is a trinomial that looks a whole lot like what we've been factoring. So I'm going to hang on to the 2 because it is a factor. And I'm going to set up my 2 parentheses because I might be able to factor the trinomial factor further. Trial and error. This is the first 2-step problem we've looked at. Signs. Okay, the last one's positive. Both match that. Plus and plus. I need an x and an x. Because the outer is positive and the inner is positive, I know that I'm looking for a sum of 28. Okay? All right, so I'd start with 48. Is 1 and 48, the sum has to equal 28. Will that work? No, 1 plus 48 will not give you 28. So let's see. 2. It's 2 times 24. Is 2 plus 24 going to be 4? I'm so sorry. Okay. Y'all are looking at me weird, and I finally caught on to what the weird look was. I needed to forget about this original one and only focus on, so this mistake will be recorded on video. Yes, to my embarrassment. I need to be focusing here, so I need a little help. I'll have to highlight things so that I'll see them correctly. My sum is not 28. My sum has to be 14. Now, the answers to my questions remain the same. 1 and 48 don't work. 2 and 24 don't work. But I was wrong before. All right, does 3 go into 48? Yes. It's 3 times 16. We probably don't carry that pair around in our head, but does 3 plus 16 equal 14? No. 4 goes in there. 4 goes in there how many times? 12. Is 4 plus 12 14? No? Okay. How about 6? 6 goes in there 8 times. Is 6 plus 8 14? Yes. So 48 had a lot of choices, and it was the last one that worked. 6 and 8. Now, to check this problem fully, it would take 2 steps to check it. First of all, I would check with FOIL. X times x is x squared. The outer product is 8x. The inner product is 6x. Those add up to be 14x. And the product of the last is 48. To fully check it, then I would distribute 2 and get 2x squared. 2 times 14x, 28x. 2 times 48, 96. It took 2 steps to factor it. It would take 2 steps to check it, if you were so inclined to check it. Your final answer to get credit must include the 2, the x plus 6, and the x plus 8. And there is not a rule about what order those need to be written. So you could have 2 times x plus 8 times x plus 6. Commutative property of multiplication says they're both right. All right. I would like you to try number 9. It is 4x squared plus 16x plus 12, and I'd like you to factor that completely. Okay. Some of you are through and some of you might not be, but if we join together, is there a common factor?
Yeah.
Okay, what is it?
4.
4. Now, somebody might have said, well, I thought the common factor was 2. 2 is a common factor, but why is that not correct?
Because
It's not the greatest common factor. So I want the biggest one, and that would be 4. So if I factor 4 out of that, it's going to give me x squared plus 4x plus 3. And looking at that trinomial factor, it looks like the problems I've been working on. It has an x squared and an x term and a constant, and I'm going to give it a shot. Don't lose the 4. Signs. The last sign is positive, which means take the sign of the middle and write it down twice. To get x squared, I know I need x and x. Am I going to be looking for a sum or difference to equal 4?
Sum.
A sum, because they were the same. So the sum has to equal 4. So I'm going to have, for the number 3, well, I'm a happy camper, because 3 is a prime number. So I only have 1 and 3. Is there some 4? Yes. And so I'm done. And certainly you could check it. I'm going to perhaps not check these as frequently in class, but I do recommend that you check them. Okay? Let's look at 10. Let's factor 4x to the third minus 20x squared plus 24x. Do you see a common factor? Yes. Okay, what will go into all these numbers? 4. Is there a common variable? Yes, x, because remember I take the low power. If I divide each of these by 4x, that's going to give me x squared minus 5x plus 6. Does this trinomial look like something I should be able to maybe work on by trial and error? Yes. Don't lose the 4x. And something that I probably need to keep doing is highlighting that so that I focus on it and I don't just get crazy and start going to the wrong thing. Tell me about the signs. The last sign is positive. Both negative. Both negative. So I know that I need an x and an x. I'm going to have to, you tell me, will I be looking for a sum or a difference to equal 5?
A difference.
Both are going to be negative. The outer product will be negative something. The inner product will be negative something. When you add two negatives, you add them. Okay, so it is a sum. The sum has to equal 5. All right, to get a 6, 1 times 6. Is 1 plus 6 going to equal 5? No. 2 times 3. Is 2 plus 3 going to equal 5? Yes, then that's my choice. Now, see, you have to be so careful on this one because 6 is a weird number when it relates to 5. The sum of its factors equal 5, but the difference of the other factors equals 5. So you have to be careful. What tells you it's a sum? Signs were alike. If the signs are alike, you add the numbers and keep the sign. Is that okay? All right, let's skip a few problems. Let's go to 14. I have x to the 4th minus 12x to the 3rd minus 28x squared. And I'm supposed to factor that. What is the first question? Is there a common factor? Yes, x is in all of those. What power of x can I take out? X to the 2nd. You take the low power out. So x to the 2nd is my common factor. If I divide x to the 2nd out of each one of these, I'm essentially using the quotient rule, which says to subtract the exponents. So I have x to the 2nd minus 12x minus 28. The trinomial that I'm looking at here appears to have the characteristics of trinomials that I know how to factor by trial and error. So I will keep the x squared. And would you tell me, based on the last sign, what the two signs in the factor should be? One positive, one negative. When the last sign is negative, it's always one of each. I know it's x and x. Because one of the products, the outer will be negative and the inner will be positive, will it be the sum of those quantities or the difference of those quantities that equals the 12? Difference. That's kind of, ooh, that is a mess. I hope that you can remember if they are different, it's difference. If I could write neatly enough. Okay, so I am focused on this trinomial right now. 28. Is it 1 times 28? Do those have a difference of 12? No. All right, 2 times 14. Do those have a difference of 12? Yes. I don't care about anything else. I know 4 times 7 would work, but I don't care because I found it. Now, if all you want to do is randomly throw them in there and check it, you could do that. If the sign turns out to be wrong, you change it. You change the signs. But let's be a little wiser than that. Their difference is 12. But it's a negative 12, which means the dominant or the big number had to be negative. So we should get it right if we put 14 there and 2 there. And then we double check. X times x is x squared. The outer product is negative 14x. The inner product is positive 2x, which does give me a negative 12x. And the product of the last is negative 28. Is that okay? Now, a characteristic that every trinomial in this section had was when it came time to do trial and error, the coefficient of the squared term was a 1. Maybe it didn't start out as a 1, like number 10 did not start out as a 1, but by the time you got the greatest common factor out, the leading coefficient was a 1. What that did was make it so much easier to figure out what to choose. Section 6.3, that will not be the case. Okay? If you happen to have taken Math 307 with me, we didn't do section 6.3, okay? All we do in there is 6.1, 6.2, and 6.5. So this next section most probably will be new to you. So I'm going to go to section 6.3, but I'm going to stop for just a minute.